guys, didn't see you there. You just caught me listening to one of my favorite songs, The Sign, made popular by the Swedish pop group Ace of Base. Well, that reminds me, we got to talk about the sine curve today. So, let's dive right in. Today, we are going to talk about the graph of the sine curve, and we are going to use what we know about the unit circle to help us graph it. So, here is what I want you to start by visualizing, okay? So picture the unit circle is actually a Ferris wheel. And I am going to highlight, that's not what I wanted to do. Okay, so we're picturing this, the unit circle is a Ferris wheel, and what I just highlighted in blue is actually underground. So you're on this Ferris wheel and you go up and you go over and then you hit the ground, and there's like an underground portion where you can go underneath the ground and you're still on this Ferris wheel and it's still a super fun ride. So here's what I need you to think about. Your position where you're at is that's created by your angle. So the angle that you make, like where your cart is, are these little dots, right? And that angle is your input in the graph. So the angle, theta, is your input, all right? Your output in this case is when you're on that Ferris wheel, how high above the ground are you? So the output really in this case is it's your height, right? That's the sine of that angle. Right? Remember, x comma y is cosine comma sine. Okay, so the y coordinate is your height and that sine. So when we're graphing it, that can help us. So let's start by just filling in a table. All right, at 0 degrees, my y value, my sine, is also 0. Moving my way around the unit circle, 90 degrees has an output, has a y value of 1, 180 degrees has an output of 0, 270 has a y value of -1, and 360, we're back at 0. All right, so basically what we're saying here is at the start, when you get onto the Ferris wheel, you're 0 feet off the ground, right? Or whatever, 0 units off the ground. You're starting on the ground. At 90 degrees up here, when your carriage is all the way at the tippy top, that is 1 unit, right? You're one unit high above the ground, right? And then at the -1, you're 1 unit below the ground. The x-axis, again, is the ground. So I'm just going to start by plotting these points, okay? Just getting them from the table. So start at 0, 0. We're starting at our origin. 91, that's right here. 180, 0, right there. 270, -1, okay, beautiful. And 360, I'm back to my starting point. I'm back at 0. I've rotated once around that Ferris wheel. Okay, so this gives me kind of like a broad idea of what my sine curve is going to look like, but I might want to get some more values on there. So if I look at, let's say 45 degrees, it's halfway between 0 and 90, seems great. My y coordinate there is √2/2, which, if I look down here, I already found for you, is about 0.71, almost 3/4 of the way between 0 and 1. So I'm going to go halfway between 0 and 90 for my x, almost 3/4 of the way for my y. There it is. Okay, I'm getting a little bit better of a picture. Let's do the same thing with 135. Okay, I'm at the same height. All right, same thing for 135 degrees. Now let's look. Let's say I'm picking the halfway points here. So 225 is halfway between 180 and 270. And now my height is -√2/2. So instead of being at a positive 0.71, I'm at a negative 0.71. Halfway between 180 and 270, I'm at a negative, almost 3/4 of the way. And then for 315, same spot, -√2/2. So just about here. Okay, so that's a pretty good looking okay, I get the deal. I get kind of a picture of what it looks like. I'm going up. I get the highest point. I start going down, okay? Right here, that's where I would hit the ground and start going underneath the ground, get to the lowest point. I come back up, okay? Now let's think about this. If you're on this Ferris wheel, could you go around twice? Well, yeah, you could, right? So this curve is going to continue going over there. If you got on this Ferris wheel, could you start by going backwards, right? Well, yes, you could. So this is also going to extend in that direction. So there's my sine curve. It looks great, all right? It's like a wave, right? Two things that I really want you to remember about the sine curve. Where does it start? Okay, sine is the height above the ground. Where does it start? How high are you off the ground when you get on that Ferris wheel? Well, you better be on the ground, which means that your graph is starting at the origin, right here. Okay, and what happens once that starts going? Well, the Ferris wheel, you're going up. You're raising in height. Sine soars. It goes up. Key thing to remember there. All right. Next, let's talk about cosine. All right, so cosine, similar type process. All right, my input is still my angle theta, but now this one's a little bit more difficult to visualize. Okay, so you're still on this Ferris wheel, but now instead of saying for like sine, we say how high off the ground are you? For cosine, what I need you to picture is you're on this Ferris wheel, and now you've got this pole that goes down the middle, right? Your y-axis. The cosine tells you how far away from that pole are you, okay? Your output in this case is the cosine because we're taking cosine of the angle. So cosine, and it's basically telling you like if you picture the Ferris wheel, you get on the Ferris wheel right here. How far away from that pole, that center pole are you? Well, you're 1 unit away. Okay, so at 0 degrees, I'm 1 unit away. At 90 degrees, and once again, I'm looking at for 0 degrees, now I'm looking at the x-coordinate in my unit circle because that's what gives me cosine. At 90 degrees, I'm looking at my x-coordinate. I am 0 feet away from that pole. I could touch that pole if I wanted to. All right, at 180, -1, I'm to the left of that 1 unit. 270, I am once again right back at that pole. 360 gets me back to 0, right? And I'm back at 1. So let me plot these points. 0, 1. Okay, so I'm not starting, what happened there? I'm not starting at the origin again. I am starting at the point 0, 1. Okay, now translating all of these points from this table up top to here at 90 degrees, 0, that's when I hit the pole. 180, I'm at -1. 270, back at 0. 360, I'm back at 1. All right, so now I'm going to put in those kind of like 45, 135, the halfway points there just to get a better look at my graph. So at 45 degrees, if I look at my unit circle, at 45 degrees, my x-coordinate is √2/2, which is that 0.71. So 45 is halfway between 0 and 90. Okay, once again, I'm going to that 0.71. At 135 degrees, halfway between 180 and 90, so right here. All right, well, now my x value is -√2/2. So I'm going to plot that as my output. Now I'm at how far I'm away from that pole. I'm at -0.7. All right, then I look halfway between 180 and 270 is 225. What's my x-coordinate there? Once again, it's at -√2/2 or -0.7. So about here. And halfway between 270 and 360 is 315, which my x-coordinate is √2/2, which is my positive 0.7 right here. All right, so this has given me kind of a nice view of what my cosine curve looks like. I'm starting over here, I'm going down, getting further away, okay. and then it comes back up. Looks like this. Once again, I know that it continues. The cycle is going to start repeating on both of these sides, okay? So the key things that you need to know about this are, if your graph wasn't transformed at all, right? Just the basic cosine graph, you are not starting at the origin, you're starting at 1, all right? And if sine soars, which remember that, if sine soars, what does cosine do? Cosine crashes. It goes down, okay? So sine starts at the origin and it soars, it goes up. Cosine starts above the origin and it crashes, all right? Unless it's transformed, which we will get into later. Super exciting stuff, right? So you've got these basic ideas of what sine and cosine look like. And again, both of those graphs are going to continue to repeat, right? Like think about like, I love Ferris wheels. I'm going around this Ferris wheel 200 times, right? Keep going, keep going, keep going. Super fun. That's what happens with those. Next, I want you to pause the video right now and read about the super important vocabulary that's listed for you right on your screen right now. Okay, so you guys learned about some super important vocabulary. First of all, a period. A period is the length of one full cycle. So when we looked at the sine curve, right? When we looked at this shows one full period, right? You start, you go up, you go all the way down, you come back up to your starting point. One rotation going around that unit or around the Ferris wheel, right? That is going to be one full cycle. And an easy way to kind of find that on the graph is the horizontal, it's the distance from peak to peak, okay? When does this graph start repeating itself? Well, first of all, let's talk about this. Is this sine or cosine? Is this a sine or a cosine graph? Oh, you know it's a sine because it soars. It starts at the origin and it soars. Great. Okay, so now the period is the distance between two peaks. So it looks like here's one peak and here's another peak, right? What is the distance between those two peaks? How many degrees are between them? Well, if I do 450 minus 90, 450 minus 90, I get 360, which should make sense because it takes 360 degrees to go around a circle. So the period here is 360 degrees. Okay, now let's talk about the midline. The midline is half of the distance. It's halfway between the maximum and the minimum. Okay, so it's the midline. It's kind of what goes in the middle. So if you look at this, let's find a different color that we can use. So as I'm looking at this, here I've got, again, let's use the same like peak. That's the highest point, right? That is at +1. And then I've got this lowest point over here, and that is at -1. So if I look at that, right, and I go halfway in between that, well, halfway between one, a +1, and a -1 is just 0. So in this case, it's pretty easy to see. So if I want to draw in that midline, there it is, approximately, right? That wasn't the best. So the midline is at 0, and it always has to be in the form y equals something. So my midline is at y equals 0. Now the amplitude is the vertical distance from the midline to the maximum or minimum point. So I'm looking at this and I'm saying, here's my midline, right? And then my maximum point was right up here, right? What is that distance between the midline and the maximum point? That's 1 unit, right? I could do the same thing if I went here from the midline to my minimum point. That is also 1 unit. So what is my amplitude? It is 1, all right? Now, domain and range, we have been talking about this literally since the first unit. So my domain is how far left and how far right does it go? Well, this is going to keep on going over here, right? This is going to keep on going over here, right? So my domain is all real numbers. It goes all the way. My leftmost point is negative infinity, less than x, less than infinity. Or I could say all real numbers. My range, well, I already talked about my lowest point and my highest point. My lowest point in my range, my lowest y value is down here at -1, less than or equal to, my y actually does hit that. And then my highest point is right up here, right? At 1, less than or equal to 1. It does hit that. All right. So a lot of things are going to be kind of the same, at least as we're introducing these, like without any transformations. Looking here, for my period, let's look at these two peaks. Okay, the distance in between them from 0 to 360, 360 degrees. It's not so bad, right? And then as I look at my midline, if I look at this like topmost point right here and this lowest point here, once again, my topmost point is at 1, my bottommost point is at -1, and halfway in between there, once again, is at 0. So I can draw in this line. That was pretty bad where I started. So, oops. There, that's great. Oh. There. Fine. It's fine. Okay, so once again, oh no. Okay, I was able to get it in there. Once again, my midline is at y equals 0. And then my amplitude is going to be actually the same thing here. So I know that here is the distance between my midline. So here's my midline, and here is my peak. And that peak is at 1. So this distance here is also 1. Same thing here. Here's my midline. Here's my lowest point. Distance there is also 1. All right. So my amplitude is 1. Now let's talk about domain and range. Once again, this is going to keep going to the left. This is going to keep going to the right. Domain, negative infinity, less than x, less than positive infinity. So what that is. And then for my range, my lowest value is 1, less than or equal to y, less than or equal to 1. All right, so that is it for today. Go out, enjoy your day. Think about sines soaring and cosines crashing. Remember that for Monday. You will need to. We'll talk to you soon. Have a great day.